See the order statistic. In this, let us consider x1, x2, so on, xn be NIID random variables of each with cumulative distribution function f of x. We can arrange the given data into ascending order, that is x with order 1 less than or equals to x with order 2 less than or equals to so on, x with order r less than or equals to so on, x with order n. Means we are taking one random variable, that is x1, x2, so on, xn with cumulative distribution function f of x, and we are arranging these random variables in ascending order, that is x with order 1, x with order 2, so on, x with order n. Okay, this x with order 1 be the first order statistic, x with order r be the rth order statistic, x with order n be the nth order statistic. Okay, we are calculating the value, that is x with order 1, which is equals to minimum of x1, x2, so on, xn from the given random variables, which is the minimum value, that is equals to x with order 1 value. Similarly, x with order n, which is equals to maximum of x1, x2, so on, xn from the given random variables, which one is the maximum value, that value equals to x with order n. Okay, after that, for this order statistic, probability density function is f of x and distribution function is capital F of x. Okay, after that, see one example. Let us consider some random variable, that is 5, 7, 3, 6, 4, 9. Consider this one has x1, x2, x3, x4, x5, x6, and we are writing this in ascending order, that is 3, 4, 5, 6, 7, 9. Okay, that is x with order 1 less than or equals to x with order 2 less than or equals to x with order 3 less than or equals to x with order 4 less than or equals to x with order 5 less than or equals to x with order 6. What we have done here, that one only we are done here. Here also we are taking one random variable with n, we are taking IID random variable and writing in ascending order. Here also we are taking some random variables and writing in ascending order. This is the order statistic definition. This is the definition and this is the example. After that, see distribution function of nth order statistic. For this, see here distribution function of x at n equals to probability of xn less than or equals to x. We have written this one from this formula, that is this is the formula of cumulative distribution function f of x equals to probability of capital X less than or equals to x. In place of x we are having xn. Why? Because we are calculating for nth order statistic. Okay, in next step, see here probability of xi less than or equals to x, where I running from 1 to n. See here at this is the x with order n only, that is nth order statistic only. So here x values live starting from 1 to n. Okay, starts from 1 and ends with n. So I am writing that is xi less than or equals to x and substituting the values, that values 1 to n, that is probability of x1 less than or equals to x intersection x2 less than or equals to x intersection x3 less than or equals to x, so on intersection xn less than or equals to x. Okay, these are IID random variables, means we can write separately also. It is possible for it is possible to write separately, that is probability of x1 less than or equals to x into probability of x2 less than or equals to x into probability of x3 less than or equals to x, so on into probability of xn less than or equals to x. If you compare this with this formula, which is equals to f of x only, so I am substituting that here, f of x into f of x into f of x up to f of x. Means these are up to n values only, so I am writing that is f of x whole to the power of n. This is the distribution function of nth order statistic. After that, we are having distribution function of first order statistic, that is f of x at first, f of x at 1 equals to probability of x with order 1 less than or equals to x. Similarly here I'm applying the condition, that is wherever we are having probability of x less than or equals to x, which is equals to 1 minus probability of x greater than x only. So I'm applying this formula here, 1 minus probability of x with order 1 greater than x. Here also we are calculating x with order 1 from these random variables, that is 1 to n only. So I'm substituting that one, xi greater than x, where I running from 1 to n. Okay, that is 1 minus, I'm substituting the I value here, probability of x1 greater than x intersection x2 greater than x intersection so on xn greater than x. Okay, these are IID random variables, means we can write separately also, that is 1 minus probability of x1 greater than x into probability of x2 greater than x so on into probability of xn greater than x, means these are up to n values. So I'm writing, that is pi I running from 1 to n, probability of xi greater than x. Once again I'm applying this condition here, that is 1 minus probability of xi less than or equals to x. This is similar to this one only, that is probability of x less than or equals to x only, this one, this term. So we can write f of x also. So I'm substituting that one here, 1 minus f of x. See here I running from 1 to n, means we are having n terms. So I'm writing that one, 1 minus f of x whole to the power of n, which is equals to 1 minus of 1 minus f of x whole to the power of n is the distribution function of first order statistic. So this is the definition of order statistic, and these are distribution function of nth order statistic and distribution function of first order statistic.